Hello students, let us solve a problem from NEET UG Paper 2019. Here is a problem. In this problem it is stated that a solid cylinder of mass 2 kg and radius 4 cm rotating about its axis at the rate of 3 rpm. Then you have to find out the torque required to stop the cylinder after 2 pi revolution. So the solid cylinder is rotating. You have to stop the cylinder. So to stop the cylinder, work has to be done by the torque. And from work energy theorem, the work done by the torque will be exactly equal to the change in the kinetic energy of the rotating cylinder. And here the cylinder is rotating. There is no translational motion. Therefore, kinetic energy will be only rotational kinetic energy. So then we can write the equation. This is the work done by the torque to stop the cylinder, rotating cylinder after theta angular displacement, and this side is the change in the kinetic energy and rotational kinetic energy, where omega is the angular speed. So omega is initial angular speed and omega is final angular speed, and I is the moment of inertia of the rotating cylinder. Okay, now let us find out what is theta, I, omega I and omega f from the informations given in the problem. So omega I can be found out from the rate of rotation given here is 3 rpm. So from 3 rpm you can find out the initial angular speed. So rpm you have to make it rps, then you have to multiply 2 pi to get the angular speed. So 3 rpm divided by 60, it becomes rps, that is the linear frequency, and along with that if you multiply 2 pi then you get angular speed. So this is initial angular speed, and the cylinder has to be stopped. That means the final angular speed has to be 0. Now the cylinder is stopped after 2 pi revolution. So one complete revolution corresponds to 2 pi radian change of angle, or 2 pi radian of displacement. Then for 2 pi revolution it is 2 pi into 2 pi, that is 4 pi square radian would be the angular displacement of the cylinder. And I, that is the moment of inertia of the solid cylinder about its own axis, and that is given by mr square by 2. If we put the value of m, r in proper unit, in SI unit, we will get this moment of inertia to be 16 into 10 to the power minus 4 kg meter square. Now if we put all these values over here in this equation, then we will be able to find out the value of torque. Here negative sign is given because the right hand side also will be negative, because final velocity, angular velocity is going to be 0. So to balance or cancel the negative sign out from both sides, so negative sign is given here. So let us put the values. Then if we do little bit of simplification, mathematical or algebraic simplification, then we reach to the answer that the torque will be equal to 2 into 10 to the power minus 6 Newton meter, and hence the first option will be the correct answer for this question. Thank you.